So you've got these three different philosophies: the perfectionist, the pragmatist, and the sprinter. How do they actually stack up in the real world? Well, an experiment using 20 different data sets gives us the answer, and it really puts the strengths and weaknesses of each one right under the microscope. Now, check this out. What's so cool here is that the results perfectly confirm what these tools were designed to do. HMA, our perfectionist, is the clear winner when it comes to capturing those tricky intra-table trends. HSA, the pragmatist, is right there in the middle doing a solid job. And the independent sprinter, it's last, which is exactly what we expected. But hold on, the story flips a little bit. When you look at the quality within each table's intense focus on the connections between tables actually means it does a slightly worse job capturing the patterns inside each one. It's a fascinating trade-off, isn't it? So you might be thinking, HMA is the clear winner, right? It seems to have the best quality. But quality, well, that's only half the story. For any real project performance, how fast you can actually get your data is just as critical. And wow, this chart right here, it just lays the massive trade-off bare. To process all 20 of those data sets, HMA took about an hour. HSA finished in under a minute, and the independent synthesizer, it was done in less than 30 seconds. I mean, that's not a small difference. That's a completely different universe of speed. This difference becomes especially clear in our enterprise deployments. In one case, for a 3-table dataset where one table contained 3 million records and each table had 30 to 40 columns, HMA took 27 hours to complete, while HSA finished in just 8 minutes. At the other end of the spectrum, HSA successfully modeled and sampled a dataset that had 200 tables, over 10 gigabytes of data, in a few hours, while HMA was unable to run at all. This dramatic difference is exactly why you hear customers say things like, "These speedups are insane." Because in the real world, with way bigger data, this is the difference between waiting for days to get a dataset versus being able to iterate and experiment in just a few minutes. It's a game changer. So after that whole showdown, which synthesizer wins? Well, like with most powerful tools, the answer isn't that one is just better than the others. The real answer is it totally depends on what you're trying to do. It's all about picking the right tool for the job. So let's break it down. Here's your cheat sheet, your game plan. If you're doing a small proof of concept and you need every last detail to be perfect, HMA is your champion. For a big enterprise project where you need a good balance of accuracy and speed, HSA is the pragmatic choice, no question. And if speed is absolutely everything, and you're okay with ignoring those inner table trends, then the independent synthesizer is the clear winner. And that really brings us to the final question, and it's a question for you. Now that you know these trade-offs, this fundamental tension between getting every little detail right and just getting it done lightning fast, how are you going to approach your next synthetic data challenge for your specific goal? What matters more?